A very good morning to you all, dear children. I'm very glad that you have done the Google Forms very well, and I hope you cannot find those answers in the internet. They are my own questions, but even then, you have got good marks 10, 9, 8, 7. So, my sincere appreciations to all of you. Now, I will give you a quick recap of what we have done in the last classes. We have started with motion. So a change in position is called motion. So when I change my position according to the time, then that is called motion. In that motion, we have said distance and displacement. Distance is the total distance that is covered. Displacement is the magnitude value between the shortest distance between the initial point and the final point. Distance is a scalar quantity, displacement is a vector quantity. From there, we moved on to velocity and acceleration. Velocity, it is a speed with some distance that we have done. And after that, we have done acceleration. What is acceleration? Changing velocity. When there is constant velocity, acceleration is 0. When there is a change in velocity, then there is acceleration. When the velocity is positive on the same direction, then acceleration is positive. When the velocity falls, then acceleration is negative. That's what we have seen. Now we are coming into the next part of this lesson, that is graphical representation of motion. In this graphical representation of motion, we are going to see two main parts. It's very easy way of finding speed and velocity and distance. Okay, what we are going to do is the first part is distance time graph, and the second part is velocity time graph. There are two graphs. Distance time graph and velocity time graph. So in distance time graph, what we are going to find? We are going to find speed. Only there are three things. I have said initially the most important formula is speed is equal to distance by time taken. Very important formula. With this formula, I have said you can solve any number of problems. Okay. So in these three things, in distance and time, what is the other thing? Speed. So we are going to find speed. In velocity time graph, what is the thing? In velocity time graph, what is the thing? Distance. So we are going to find distance. In that graphical representation, there are two parts. First one is uniform speed and next one is non-uniform speed. In the first one. In the second part, we are going to do constant velocity and the velocity or speed changes uniformly. So these are the things we are going to see in this lesson. First, we are going to see distance time graph. In the distance time graph, what is missing? Speed is missing. So we are going to find speed with the help of graph. So we are going to find speed with the help of graph. So if I say graph, you might be wondering what is graph? How do I understand graph? If you have the habit of watching cricket, it's very easy. In between the overs, they will project their graph, a run rate graph. How is it? This side is runs, this side is overs. 5 overs, 50 runs. So let us take 5, 10, 15, 20. 20 match. 5 over, 50 runs. 10 over, so 5 overs, they got 50 runs. And 10 overs, they got 100 runs. And 15 overs, they got 150 runs. And 20 overs, they got 200 runs. So what is the run rate? Simple, this is the graph. What is the run rate? Slope of this graph. That means y by x is the run rate. That means what is y? This is y, 200. What is x? 20. That means 100 is 10. So you understand what is graph? Simple. I am going to this graph from the known example what you know. From there, now I am coming to distance, time and speed. So what you're going to do, time is always in x-axis. This is time in seconds or minutes. Y-axis, distance. That's all. So in distance time graph, first we are going to see at constant velocity, constant speed, uniform motion. So uniform motion. What is uniform motion? Uniform motion means a person or a vehicle which covers equal distances in equal intervals of time. That is called uniform motion. That means uh, for example, uh, for this I call it 1 minute. Say, excuse me, x-axis is time for 1 minute. For 1 minute, for 1 minute, my vehicle covers 10 kilometers. For 2 minutes, it covers 20 kilometers. For 3 minutes, it covers 30 kilometers. That means 1 minute, it covers 10 kilometers. For 2 minutes, it covers 20 kilometers. For 3 minutes, it covers 30 kilometers. That means when I form, it will come as a straight line. So straight line is a graph for uniform motion. For a uniform motion, this is a straight line. So how I can find, so what we are going to find? So when you take a practical example, when you are going in a car from Maraimalai to Chengalpet or Vilupuram or Trichy, so you are covering, you know the distance. For 8 o'clock you are starting, 8:30 you are reaching one point, 9 o'clock you are reaching one point, 9:30 you are reaching one point, 10 o'clock you are reaching one point, and the distance are same. And your dad is asking, can you calculate the speed of a vehicle? Yes, you are going to calculate. How you are going to calculate? For any point, or any point. Okay, any point. Draw a perpendicular line for x-axis and a perpendicular line for y-axis. Okay. For example, take 2 points. This point is A, this point is B. Draw a vertical line, draw a horizontal line. So, I am calculating what is the speed of the vehicle in the interval of time A and B. In this interval, what is my speed? We know that is a constant speed. What is the speed? Now, what is the speed? Speed is equal to distance by time taken. Distance by time. So I call this is T1, T2. This one S1. Distance is mentioned S1, S2. So S2 minus S1 divided by T2 minus T1. That is called speed. Yeah, this is called slope. Slope of a line. Slope of a line is called speed of the particular graph we can find with the slope of the line. Slope is y by x. This is called slope. So from this graph we are finding what is speed. So for uniform motion, it is a straight line. So what about a non-uniform motion? Non-uniform motion means it covers different distances at same period of time. For first, for example, I can draw what would be this for first 1 hour the vehicle is moving at different speed. For the next 2 second minute, it is moving at different speed. So the motion is not uniform. For a non-uniform motion, you cannot get a straight line, but a curved line. So when you calculate, this will be 1 point. Initially, this will be 1 point. This will be another point. This will be another point, and this time. So for non-uniform motion, it is not a straight line. For uniform motion, it is a straight line. But speed is calculated dy by dx. That means y by x. That is, what is y? Distance by time. This is a very important thing that I want to say. Yes. Now, we are moving into the second part. What is the second part? I hope you remember. That is velocity time graph. In velocity time, what is missing? Distance is missing. So we are going to find distance. So in the first graph, we are finding speed. In the second, we are going to find distance. So velocity, ultimately velocity x-axis, time x-axis, velocity y-axis, x-axis, y-axis. Okay, now what is the first condition? First condition is constant velocity. Constant velocity. Constant velocity. So the time is not dependent on time. For example, for 0 or for 1 hour, 2 hours. So this time can be in hours, it can be in minutes, it can be in seconds. For 1 hour, it is going at one speed. Constant velocity. For second hour, it is going at same speed. For third hour, it is going at same speed. What would be the graph? What is the speed? For example, you take 40 km per hour. It is going at constant speed. If it goes at constant speed, it is a straight line. Graph is a straight line. So what we are going to find? Distance. How to find a distance in this time? A, B. How to find a distance when it moves at a constant velocity? So your car is going at 40 km per hour, 60 km per hour, and the father is asking, we are going at constant speed. How much distance we have traveled in this time? From 9 o'clock to 10 o'clock, we are going at 40 km per hour. So what is the distance covered? The father is asking. So immediately you are going to calculate. Okay. Draw a perpendicular line. Draw a perpendicular line. Okay. The area covered by this rectangle is the distance. So distance is equal to area of rectangle. Distance is the area of the rectangle. So for example, when I call it C and D, what is the area of rectangle? L into B. L into B. What is L? L is this length, right? Length. 40 km per hour. What is B? I call it T 1 T2. So 40 kilometer into T2 into T2 minus T1. T2 minus T1, 40 kilometer. Length into breadth. So this is how we are going to find about velocity. So what I said, distance, to measure the distance is measured by the area covered by the graph. So in that way, when I shade it, it comes, there is a triangle and there is a rectangle. So what is the area of, so ABCD rectangle and ADE is a triangle. Area of rectangle and area of triangle. What is the area of rectangle? L into B. Okay. L into B. What is the area of triangle? Half into base into height of BH. So if we calculate in that way, AB into BC plus half into AD into DE. Okay. This is the area covered by the distance covered by the vehicle. So we have learned two important things from two important graphs. First one is velocity. This is velocity. This is distance time graph. From the distance time graph, we are finding speed or velocity, that is the slope. Simply distance by time, that is the slope. Very important thing. In the second graph, velocity into time. In this graph, we are finding distance. How we are finding distance? The area covered by the graph is the distance. Okay. Hope you understood the things. It's very easy. I will give you some problems and some questions in Google Forms, and I expect you to do well. Thank you.